In Chapter 7, we are going to start looking at some of the more abstract concepts within chemistry. You'll remember back in the beginning of the semester, we talked about matter, and we said that matter was anything that had mass or volume. And we talked about how pretty much everything that's anything is going to be matter. But one of the things that is not matter is energy. Okay. Energy is defined as the ability to do work. Okay. So if something has energy, it can do work. If it doesn't have energy, it can't do work. Okay. Now, energy comes in a lot of different forms. Okay. And we're not going to talk about every one of these forms. But the important thing to remember about energy is that it is neither created nor destroyed. So in other words, if you think about all the energy that exists in the universe right now, that's the same amount of energy that was present at the inception of the universe. Okay, so the total amount of energy doesn't change. Now, that's not to say that energy can't change forms, because it can. If you just think about a nuclear power plant, utilizes nuclear energy, which we'll talk about in Chapter 9, but it converts that nuclear energy into heat, and that heat then causes a propeller or impeller to turn, which generates electricity, and we're able to transmit that electricity to our homes, where we use it to do things like, watch YouTube videos on our laptops. Okay, so we can take energy and have it change forms. Okay, now, in terms of a chemical reaction, energy is usually described in terms of heat. Okay, and you may have experienced this at some point in your own lives. But if we were to create a hypothetical vessel, a flask maybe, or a box, okay, it's important for us to be able to define the parts of the universe relative to this vessel. Okay, so everything that's taking place inside of the vessel is called the system. Everything that's taking place in the rest of the universe is the surroundings. Okay, so basically, everything that's happening with the system plus everything that's happening in the surroundings is pretty much everything that's happening in the universe. Okay, and when we do things within a system, that system can interact with its surroundings. And one way that it can do that is by transferring heat. Okay, so you may have noticed that some processes can generate heat, which means the system is giving off heat to the surroundings. Okay, some things actually can take heat in. Okay, so taking heat away from the surroundings and putting them into the system. Okay. When heat is being given off from the system to the surroundings, we call that process exothermic. And if the system is taking in heat from the surroundings, we call that endothermic. Okay, so exothermic means giving off heat, endothermic means taking in heat. Now, this raises the question, how is it that the system is able to do these transactions where it gives off heat or takes heat in? And to understand that, we need to understand the nature of a chemical reaction itself. Okay, so consider if we had a reaction of some compound A, and it doesn't matter what it is, being converted to some compound B. Okay, we could describe this reaction in terms of its, we call it the energy profile, where we look at the energy of the components of the reaction over time. and time in terms of as the reaction proceeds. So we'll just call this reaction progress. So early in the reaction, all we have is A. And let's say that A, if we take into account how fast it's moving around and how big it is and all that sort of stuff, let's say that it has an energy equal to the level that I just drew there. Okay, so that's the energy of A. Now, if we were to look at the energy of B, and let's say in this particular case, B is lower in energy. Okay. Okay, that's the energy level for B. In the course of this reaction, we're going from a high energy reactant to a low energy product. Okay, so what this means is that we're losing energy. So we're going from high energy to low energy. We have to lose energy. Well, energy can't just disappear. Energy has to go somewhere, like we said earlier on. And that energy that's being lost is being given off as heat. Okay, so in a process where the products are more stable or lower in energy than the reactants, heat is given off, and therefore the process will be exothermic. Okay, now we would expect that most processes would be exothermic because it makes sense to go from high energy to low energy. But it turns out you can go the other way as well. You can go from low energy to high energy. So let's say we have some other reaction, call it C being converted to D. Okay, again, we'll look at the energy profile for the reaction. Okay, let's say this time A is fairly low in energy and B is higher in energy. Okay, now here we're going from low energy to high energy. Now, in order to do that, you have to put energy into the system. Okay, and the only way that energy can get into the system is if it comes from the surroundings. Okay, so heat is going to be taken in from the surroundings, and it's going to be endothermic. Now, if a process is exothermic, it's going to feel warm to the touch. Okay, that's because the heat is leaving the system, and when you're touching the flask, the heat's going to be picked up by your body. So you're feeling that heat coming in. Now, something that's endothermic is going to feel cool to the touch. Okay, and that's because the flask is literally stealing energy in the form of heat from your hand. Now, this type of energy that's kind of changing hands here is what we call enthalpy. And we abbreviate that or symbolize that with the delta H. Okay, so enthalpy is energy related to heat.